people apparently are in transit, and it looks like we have a big group here today. It's a real honor for me to moderate the session this afternoon on forests, climate, and water. We have a very diverse and experienced panel with a lot of knowledge and track record in both science, social science, policy, and implementation. And I would just start by saying I think it's a very appropriate topic to be looking at now. I think that the last 6 years have seen some long-needed emphasis on the role of forests in climate change through their ability to store carbon in their tissues. And we tried to get that into an international climate bill in 2000, and we failed. But 6 years ago, the opening came, and we are making a little bit of progress in getting that aspect of forests and that link to climate change embodied in, if not a fully operational international mechanism. At least a lot of countries are moving and taking steps to defending that aspect of forests. I think this has been a period, though, of realizing that if we just look at forests for their carbon, we're missing a whole lot. And today's session focuses on one of the other ecosystem services provided by forests, which is their links to forests through climate through water, and some of the interactions of those three, climate, water, and forests, to people on the ground. We're coming into a scary world, I'd say. I have the pleasure, or perhaps the horror, of being one of the lead authors of the IPCC Next Integrated Assessment. We just produced our first draft of what's coming our way, or what we know about the science of climate change and its impact on terrestrial ecosystems. And it's very sobering. And what permeates the latest evidence, and evidence that's been there in one form or another for many years, is that we cannot treat these aspects of these ecosystems and these climatic systems in isolation. We need integrated approaches, and we often run into policy structures, institutional barriers, disciplinary barriers to really achieving that integrated approach to natural resources that's necessary. And I would like to then begin. We're going to run this session with an initial sort of question and 5-minute answer from each of our panelists, another round of questions and answers, and then I'll give a very brief oversight of our discussion. Then we're going to open it up for about 30 minutes at the end. So if you have burning questions about this issue, please stay with us. We're going to begin with a question for Dr. Carlos Nobri. Dr. Nobri is the director of the Center for Earth System Science at INPE, the Instituto Nacional de Pesquisas Espaciais. I think it's very appropriate that Carlos be with us today, since he was really the pioneer in calling attention to the interface, the relationship between forests and climate, and the potential for a tipping point there, where forests really slide over into a different type of ecosystem and a new steady state with a lot more savanna than we have today. He's influenced my own career greatly, and it's a pleasure and an honor to have him with us today. And Carlos, I would like to begin really with, if you could just give us some of your latest insights on the role of forests in the climate of the Amazon. And in particular, what are we going to see as Amazon deforestation continues into the future?
Good afternoon to all. Thank you very much for inviting me to this session. Initially, then let me correct my current professional affiliation. I'm doing my bit on Science Policy Interface. So I'm working in Brazil now with the Ministry of Science, Technology and Innovation. I'm the National Secretary for Research and Development. But still I am trying to keep wearing my hat as a scientist. So answer your question, try to answer as a scientist. think it's very clear today that when we look at all global tropical forests, this is a more general statement. It also applies to other forests, extratropical, but this is very true for tropical forests all over the world, mostly the Amazon, also in Africa, tropical equatorial Africa, and also in Southeast Asia, but to a lesser extent because the climate over Southeast Asia is so much controlled by ocean atmospheric directions that in Southeast Asia you have to weigh the two factors, the biosphere, the forest atmospheric directions, producing a climate which is appropriate for the maintenance of forests, and also, of course, the very large scale controls coming from the ocean atmospheric interactions. The most well-known of such phenomena is El Niño, La Niña. But in the Amazon, going back to the Amazon, one might even argue that if not for the forests, there will be an X amount of savannas. This X, still we don't know, but not less than 10%, perhaps even 30%. So basically, what the Amazonian forests provide is a surface control over the meteorology of the region, in which, by such control, rainfall increases. And the rainfall increases in the most critical part of the year, during the dry season. So if not for this control provided by the fact that forests, tropical forests, any forest, but tropical forests recycle a lot of water, and Dan and other colleagues are, they had pioneering research showing how deep the roots go and how important this control during the dry season is to replenish the lower atmosphere, the boundary layer, with moisture, and that moisture is transported and it becomes rainfall. So it may look a small amount, 10%, 15% more rainfall, but at a critical time of the year. For that reason, making a long story shorter, many studies would indicate tropical forests create the conditions for their own survival and maintenance at a level that can be 10%, that could be all the way to 30%. So that's fact number one. So when you remove the forest, or replace, or you have large scale agriculture as a pasture, which is the dominant land use in the Amazon, you create a condition that the forests lack, which is dryness. And also Dan and many colleagues have been investigating the effect of dryness and fire. So fire is very common in savannas, fire is very uncommon in the forest. So this makes for a very abrupt, we would call it a non-linear abrupt change. So if you remove forests, then you facilitate the expansion of savannas. And in fact, we are perhaps start documenting in the Amazon some elements that would indicate already early stages of savanna expansion. There are some hypotheses that the dry season is becoming longer, still to be demonstrated fully, but that's what we would expect. So therefore, the complex interaction between the forest and the atmosphere provides for more rainfall and more forests and stable forests. So what deforestation does over the larger scale deforestation is that it breaks this equilibrium. And many studies, including some of my own research group, and I will just make this statement and leave it with you. Many groups are studying what would be tipping points for this equilibrium, which keeps the forest where it exists. And for the Amazon, studies are indicating that we should not transgress a maximum 4 degrees warming in the forest. That would mean 3.5 global warming, meaning a global average surface temperature change, because continents, as you know, warm up more than oceans. So global warming is 3.5. In the Amazon would be 4 or 4.5. So 4 degrees in the Amazon, that's one of the tipping points. And another tipping point also being studied is the amount, how much area one can deforest before you irreversibly change to this other stable state. This is 40%. For this, those are early quantitative attempts at getting at tipping points. So there are a lot more research is needed. But you know, if those things, let's assume just for a second, those quantitative estimates of tipping points are more or less right. So then really we have to be very far from those tipping points. So if those tipping points are okay, then perhaps deforestation should not exceed 20%. You have to really be, because you're never sure on the uncertainty. And of course, uncertainty is of all of us, cuts both ways. So you have to be very far from the possibility of tipping points. So I would say 20%. And warming to 2.5 degrees. So I would say if those tipping points are right, we should not exceed 2.5 degrees warming and 20% deforestation. In the Amazon, we are getting close to 20% deforestation. However, with the good news in the last 5-6 years in Brazil, deforestation is declining very, very rapidly. So I will stop here. Thank you very much.
Thank you, Carlos. We're now going to pass to Lou Gershot, Principal Scientist at Center for International Forestry Research. Lou has been doing a number of global overviews and reviews of the state of our knowledge of forests and their role in carbon, with particular emphasis on wetland forests. And I was wondering, Lou, if you could just say quickly, summarize for us some of the key insights on the role of wetland forests in climate, both for adaptation and mitigation.
Thank you very much, Dan. Wetlands, I think, are perhaps one of the least well-studied ecosystems from a climate change perspective, but that's changing fairly rapidly. There's a lot of work now going on and a lot of attention being focused on wetlands, particularly over the past 5 or 6 years. We know now that the wetlands are a very significant carbon store. Daniel Murray-Arso, who's leading our work in mangroves, has documented that carbon stores are on the order of 300 to 1,000 tons of carbon per hectare in mangrove forests. And mangrove forests are of particular importance for us in Southeast Asia. In Indonesia, for example, we're losing about 6% of our mangroves every single year, which means in about 25 years our mangroves are going to be gone. And so this is probably the most carbon-dense forested ecosystem anywhere in the world, and it's being lost at such a rapid rate, and it's largely left out of what people are talking about in REDD mechanisms. So that's one thing that research has showed us. But more importantly, mangroves have, Dan mentioned tipping points, and there is an important tipping point that happens when you deforest mangroves. Mangroves are often deforested for industrial fish production, for industrial shrimp production, and these areas remain in production for 8 to 10, 12 years. What happens is a slow process of acidification as carbon is lost from these sediments, and as the carbon content decreases in these sediments, we get an increase in the acidity, the pH often drops, we get sulfate reduction, and these soils end up turning into acid sulfate soils, which are extremely difficult to rehabilitate, and we lose them from productivity. So they're not good for long-term livelihood types of options for farmers. Daniel's also done a calculation sort of a back-of-the-envelope calculation on what is the carbon footprint of a shrimp cocktail. And he's figured that a 100-gram shrimp cocktail puts into the atmosphere about 900 kilograms of carbon dioxide. Okay? It's one of the most carbon-intensive meats that can be produced in the world. Okay? So that's one of the things that we know. We're doing a lot of work in peatlands, and peatlands are becoming more and more, I guess, political, because there's an awful lot of production happening on peatlands right now. In Southeast Asia, in particular, peatlands are wastelands. They're lands that don't belong to people. So as industrial plantation activities like oil palm, pulpwood, are looking for places to expand in Indonesia and in the region, peatlands are an area that are easy access, and they don't have to fight the battles of land tenure and competing claims on the land. These areas have very large carbon stores, and our estimates are that they lose on the order of 8 to 10 tons of carbon every single year that they're drained and in production. So you have the loss of carbon associated with the deforestation, but after that, every year you're losing 8 to 12 tons of carbon. And that's not carbon dioxide, so we're talking about 30 tons of carbon dioxide every single year they remain in production. And that carbon loss is much more important over the lifetime of an oil palm plantation or an acacia plantation than is the loss of the primary forest that's been lost through land clearing. And here again we have a tipping point. When you deforest and drain peatlands, you get subsidence. And what happens is these peat formations are in the shape of a dome, right? As you drain them, several processes come into place. You have shrinkage of your peat fibers, you have compression and compaction as you put machinery on there to manage your plantation. And you also get the oxidation of the peat matter. So the peat slowly subsides, and as it subsides, it gets down to the level of the water table. You have to drain even deeper. And eventually, a lot of these peatlands are likely to end up below sea level. So we're talking about a tipping point here of losing land that was important for biodiversity, important for water retention, and an important resource for many reasons. We're now talking about losing that land completely and going from a terrestrial ecosystem, albeit wetland, into an aquatic or oceanic ecosystem as these shrink below the water table, shrink below the coastline. So we're talking now about looking at greater salt intrusion as sea levels rise. These ecosystems can no longer perform their buffering function that they have been performing. As we lose the mangroves, as we lose the peatlands that are right behind the mangroves, and as sea level rises, we're likely to see greater salt intrusion inland, less land that's available for production, and less land that's available for support of fisheries and other types of activities that have been important to people living inland that would seasonally use these areas. And as we look across the globe now for peatland, because it's been a really hot issue in Southeast Asia, it's now becoming a hot issue in other parts of the world. So as scientists begin to look beyond Southeast Asia, we're finding peatlands are important in the Amazon. Peatlands are present and important in Africa, and they're underappreciated. So now I think there's a lot of scientific work that needs to go on to help us understand just how do the tipping points we see in Southeast Asia, how are they the same and how are they different in these other areas, and what are the functions of these ecosystems that are being lost as this land is being converted.
Thank you, Luis. Our next panelist is Mingsarn Kausa Art. She's the former director of the Social Research Institute and professor of economics at Chiang Mai University in Thailand. And Mingsarn, there was just an enormous flood event in Thailand, and I think we've all learned in our graduate courses that the best way to control floods is through forests in your watersheds, and that will dampen the level of flooding and increase the sponge effects, etc. But that may not always be the case. I wonder if you could explain to us this recent flooding event in Thailand, its magnitude, and what are some of the land use issues that were related to it?
First, I would like to draw your attention to the fact that the flood in Thailand last year was the third biggest disaster in terms of value. The first one was the tsunami and the nuclear plant in Fukushima. The second one is Katrina, the hurricane, and the flood in Thailand is the third one. So it's such a scale of disaster. We have a lot of lessons learned. First of all, when the flood started, it was flash flood in the northern part of Thailand because it comes down the mountain. And in the last 5 or 6 years, the government has this crop insurance scheme and a guaranteed price scheme. So what happened is farmers start growing corns up to the top of the mountain, removing forests, especially in the province corner. You see barren. I mean, in the dry season, it's all brown, but when it rains, it's all corn or maize. Because the mountain's supposed to be public land, and the farmers do not own land, so they don't own. If they grow a tree, they cannot cut the tree, and they cannot own the tree. So what they do is they grow corns and cabbages. And because of these subsidy, crop subsidy and commercialization, we have been losing forests more and producing flash flood in the north. But flash flood in the north started gathering all the water, but it took about almost a month to come to Bangkok because water has to travel. When it came to Bangkok, at that time the government did not know because you can see from the satellite that it's going to be big. It's like the sea moving down to Bangkok. But the government can't really tell how much is the water. Because we have 4 river basins in the north, and the data of the 4 basins are not connected. And we don't have water basin committee down below. When the 4 tributaries meet, and then it's a big Jaya River, we don't have a basin committee there, and we don't have connectivity of the data. We finally found out that the water is about 1,500 million cubic meters that came down. It's like sea of water running into Bangkok. So with such a magnitude of disaster, the government sure had to do something. So the government put investment in, the government has announced that it would put $2 billion to look after the upper watershed now. But it's not clear how they are going to do it. Whether they are going to grow it, if they grow it tomorrow, it will be 30 years from now. It's for not for the next flood, maybe the 30-year flood. So there are a lot of things that government should be doing that they haven't done. For example, the Ministry of Finance is planning a law called Economic Instrument Law, where you can have PES as part of the law. But PES is payment for ecosystem service. But the problem with this law is that the Council of the State is against it. The Council of State is the advisory body of the government. Because the land is public land, you cannot pay farmers who live on public land money. Because they have no right to be there. So what happened is, to do this, you have to change forest law. So there are a bunch of laws that one has to, it's not enough to have a law on PES, you have to change a bunch of law on land and land tenures. We have 20 pieces of legislation on land. So that is something we have to go through one by one to see which has to be changed. So let's stop at forests and PES. Now, although it is good news for the forester that they're getting $2 billion to grow trees and look after watershed, the engineers are happier people because they get 3.5 times more money to do to work on engineering solution. See, so although foresters are happy men, we have a happier man. The next lesson that we learned is that who's going to pay for this amount of investment? And we had a survey done to about 3,000 residents in the flooded area and asked them whether they are willing to pay to protect the watershed, to have this engineering solution. 30% said no. They said, I'm paying tax. Why should I pay more? So for those of you who are interested in performance-based payment, PES, this is an indication that there must be a lot of communication done before we can implement this kind of program. The third lesson that actually we have many more lessons, but a lot of them are not related to forests, okay? The third lesson is landscape management. We have city plans, we have town plans, we don't have landscape management plan. So in the area that was in the middle part of Thailand, just before Bangkok, it used to be swampland. And when we changed it into rice field, and because it's not a very productive area because the water is flooded all the time, and sometimes 3 meters, and you cannot grow the miracle rice, the high-yielding rice. So the land is cheap. So what happened is the Japanese start buying this land, turn it into factories. So when you turn wetlands into factories, the absorption capacity of land, the rainwater absorption capacity, which used to be 90%, became 15%. So although the flood could be not bigger, you still have much more water on the surface. So now the problem now is we need to have a landscape management plan, which we will call in this context floodland management. In order to do this, we need to have an organization that goes through different pieces of land and stick things together. It's not the best thing the government would do. So this is what I want to say for the first round.
Thank you, Ming-Sar. Our next panelist is David Ellison. David is senior researcher at the Institute for World Economics at the Hungarian Academy of Sciences. David, there's a lot of confusion, I think, about basic forest hydrology. If you say to a crowd, you cut the forest down and the streams dry up, everyone will usually shake their heads. If you talk to hydrologists, forest hydrologists who work on watershed management, they'll say, well, you cut the forest down and you decrease evapotranspiration, and that leftover water leaves as discharge. So you actually get more water. You've done some very interesting work recently in reviewing the state of our knowledge of this issue, and I wondered if you could enlighten us as to how we reconcile these.
So I will give it a try. I would first really like to underline the things that Carlos was saying about the Amazon. But I think one of the interesting things that came out of the work that I was doing, and certainly the reviews of different pieces of research, was that this is really a global, sort of a universal phenomenon. It's not isolated to individual cases like the Amazon, or to the Mediterranean, or to areas where a lot of studies have been done on precipitation recycling. But it's a general phenomenon that forests are, for the most part, positively linked to precipitation phenomena. In doing this research, I wanted to sort of, I kept on getting attacked by other people saying, well, the basic approach is that forests and forestry and their relationship to water are basically dominated by the demand side of the question. People think about and talk about how much water is available for local use. People have this local sort of catchment basin view of the relationship between forests and water. And from one perspective, it's very true. Right? Trees take water away. They suck it up out of the ground and they send it out into the atmosphere. Right? As evapotranspiration. But from this demand side perspective, in general, few questions are really asked about what happens to ET and evapotranspiration after it is emitted into the atmosphere. And that's where all the play is in the long run. That's how you get to these kinds of questions that Carlos was talking about. So my work has been partly about trying to reconcile this demand side view with what I call the supply side. What are the sources of precipitation? Not what gives you more or less runoff, but what are the sources of precipitation itself? And the basic idea is simply that what goes up must come down. Right? And a big part of the story is where ET, evapotranspiration, comes back down as precipitation. So ET, evapotranspiration, does return to precipitation both locally and at more distant locations. Right? And trees play forests and trees play a fundamental role in this process, and in particular in the cross-continental transport of moisture vapor. If it weren't for the forests, a lot of the moisture that starts as oceanic evaporation would not be able to cross the continent and become available as water in more distant locations. So trees play a fundamental role in this process. How water gets from point A to point B and is able to cross terrestrial surfaces is to a very large extent a function of forests. Forests are the most efficient evapotranspirators and producers of moisture vapor that we have, along with wetlands, which are equal. There are fewer wetlands. So most of my work is focused on forests rather than wetlands, but wetlands are the same in this basic equation. So forests have the potential to boost, to raise water availability in locations where it might not otherwise be as abundant. Or to reverse that argument, modifications of the terrestrial landscape, changes in land use practice have implications for water availability in other locations. If you deforest large areas from an upwind location, downwind locations can lose moisture availability. They will see reduced precipitation. They may see increased drought events and have less runoff in the rivers that they can use for other things. Okay. So there are, I would argue, widespread consequences of deforestation. Deforestation does have an impact on water availability. Even just from a strict water budgeting perspective, if some 50% or more of precipitation sources come from evapotranspiration, from continents, from terrestrial surfaces, then the loss of trees means a significant loss of water, some 50%, right? 40% if you're talking in annual terms, 50% if you're talking in seasonal terms. This could be sort of across the globe. In particular regions, it could be much more significant. And though there may still be somewhat mixed evidence on change in rainfall patterns in the deforestation literature, the loss of trees does mean, or has to mean, because of the strict water budget accounting, has to mean the loss of precipitation. So all in all, reduced evapotranspiration generally means reduced precipitation. Although it may also, on some occasions, lead to increased runoff, in particular in local methods. Let me go one step further and talk a little bit about some of the current work that I'm doing So the first study was done on a global basis. We looked at 9 river basins across major river basins and water management sites across the globe, and the impact of forest cover and the impact of ET on precipitation availability in those areas. So it was a very broad global study. In the current work that I'm trying to develop a very simple model that anybody who's, let's say, a water management person could use to be able to estimate the impacts of land use change on water availability in a catchment basin that would integrate and incorporate evapotranspiration flows both from outside the basin as well as the change in the evapotranspiration flows that go from the basin to other locations. So we care about both of those processes. And this is still somewhat preliminary, but it's progressing rapidly. I've already been showing slides to my colleagues a little bit about this. But one of the things that's interesting is that you arrive at some kind of a prisoner's dilemma game. Here's my political science days kicking in again. And that results in a problem that affects precipitation and runoff. So land users are in a sense locked into a state of linked interdependence. Land use changes in one region affect water availability, precipitation, and runoff in other regions. And in the same way, land use change in the local region affect water availability in downwind regions, both in terms of precipitation and in terms of runoff. Now, this is generally not that well considered or thought about in most of the current literature, but land use change can result in big changes in water availability, precipitation, and runoff. And in the long run, it suggests, because of this linked interdependence, that we really need some kind of coordination of water management practices, land management practices, at higher levels of organization. If you do this at the catchment level, something is going to get lost. Because at the catchment level, you may not care, for example, about that evapotranspiration that leaves your catchment and goes somewhere else and doesn't detect you. But somebody else might care an awful lot. So you have to think about then raising the level of water management strategies, perhaps at the national level, bilateral levels across states, or some kind of supranational organization like the EU or international organizations. And I will say one last thing about afforestation as a climate change adaptation tool. It should already be relatively clear that if forests can have such an impact on precipitation and water availability, then presumably they can also be used as a climate change adaptation tool. Now, most of the discussion about forest use is about climate mitigation, carbon sequestration in forests, and so on. A lot less of it, very little really, is about potential for using afforestation as a climate change adaptation. But I think its relevance should be already crystal clear from the things I have said. If you can impact precipitation and runoff in these ways, then forests can be used in this manner and should be thought of more consistently in this general climate change adaptation, mitigation and adaptation framework. I'll stop there for now.
Thank you, David. This next round of questions is actually more complicated. It gets more into the policy realm, but we actually have less time for speakers, so we're going to have to keep it to just a couple of minutes per, and I will be giving you little signals as to when you're getting close to your limit. Carlos, let's get back to you. I think your impact on scientific understanding, what a lot of people may not know less about is your impact on policy and the way we view forests. And as you've watched world attention focus on the carbon storage and mitigation potential of forests, slowing deforestation as manifested in red, I know that you've struggled also with how do we get a similar framework for capturing the this other global value of forests, which is its role in evapotranspiration and its contributions to global circulation patterns as we know them today. I wonder if you could just talk a little bit about the potential you see for coming up with a global regime that would value forests for their role in global circulation and climate patterns.
In fact, I'm becoming more and more convinced that the relationship between forest and water, as they have already described in detail, makes my life easier here, will become more important than carbon. This is a bold statement. This is a bold statement. I'm doing on purpose. Because if we cannot stop fossil fuel emissions, 15 years ago, deforestation globally was 25% of global emissions. Today it's 10-12%, and it will go down. Deforestation is going down globally, and the fossil fuel emissions are going up. Nobody is predicting they will go down shortly. So, not to say that red is less important. Red is fundamentally important because it's not only about carbon, it's about sustainable development for forests. But I think really water, forest water interaction and relationships will become essential. And that's really where we need to know more. There are simple things, in many countries we're talking here, my colleague here is talking about floods, and here in Brazil also we've been affected by floods, landslides, mudslides, natural disasters, fatalities. And of course, I mean, the very clear value of forests in that context is really to mitigate natural disasters, serious consequences. So that very simple, localized, but very important for most very urban areas, major cities in the world, particularly developing nations. A more important issue that's still open, we have to really to scale up. When we look at forest water, hydrology, then we can more easily see the value. For instance, payment for ecosystem services for maintaining forests to make the streams flowing during the dry season, and also for water quality. This is well quantified. We know a lot about that. Then when we move, as David pointed out, to evapotranspiration, then it's less clear. Evapotranspiration here, very efficient recycling of water, so prevents the water from reaching the streams and going eventually into the ocean, and then keeps the water in the atmosphere, water vapor, and then that's transported away from the source region, and that becomes precipitation. But then, where, when, how that becomes precipitation. And even if we can improve the scientific description of this process through extremely perfected models, computer models, still there is an attribution to be carried out. How you attribute value. And what's the value? I mean, we increase rainfall downstream. They've already mentioned that. How you attribute value. And that's on a regional scale. And then when you think about the global scale, it becomes even blurrier. But those are very important elements on the relationship between forests and water that have global importance, global consequence. If you deforest all tropical forests of the world, you change weather patterns broadly, remotely from the source regions. If you disappear with the Arctic ice during the summer, you also change the weather patterns in northern hemisphere very abruptly. And how you attribute value when you perturb the atmosphere on a major way, like Arctic ice or like tropical forests, and then you change weather patterns, you get more extremes. How you attribute value? This is a very difficult question, but I think a question that science has to face, because I think the relationship between forests and water will become more important than the relationship forests and parks.
Thank you. I think to save time, since we're running short, we'll just hold our applause to the very end of the session before we open questions. Ning-Sarn, you are in a remarkable position to think broadly about the Mekong. You've looked at it for a very long time. You've studied it from many different angles. I think all major infrastructure projects carry with them trade-offs, and there are costs and benefits of those measured by social, environmental, economic terms. I wonder if you could just say a few words of insights and lessons about the potential for hydropower in the Mekong, and could that be really rolled out? You know, how could we maximize those benefits and minimize the negatives? And is there a prominent role for forests in those solutions? Tiny little question for 3 minutes.
Yes, the Mekong at the moment is the least dammed river in the world for a major international river. And China has now started damming the upper part, but it's not called the Mekong. It's in Yunnan, it's called the Lanchanjiang, but it's the origin of the Mekong. And this is the upper part. The lower part is the Mekong, has 4 countries. And Laos has project, Laos and Cambodia has altogether 11 projects to dam the river, to produce hydropower, to sell to Thailand and to Vietnam. So for Laos, this is a really good option for them, because it's a country which doesn't have much labor, and this will give them a lot of income. If we have hydropower there, Laos will be prosperous. Then what would be the impact on forests? Well, the negative impact is when you have a dam, you open new access to forests, and people can go and do logging or do agriculture on the upper watershed, because there will have to be roads to the dam. But on the other hand, if you manage it properly, you can use what the economists are promoting, which is PES, like paying the land user to look after the forest and then get service from what we call hydrological service from the watershed, asking the dam owner to pay to the farmers. Actually, as we yesterday, if you listen to our Vietnamese colleague, Vietnam has been doing that, but Vietnam did it in the sense that it forced the hydro dam to pay without consultation. Okay, so as far as forest is concerned and water is concerned, it seems that things are doing not too bad. If we can manage properly, maybe we lose a little bit of forest, but we can still keep a lot of forest, and we get a lot of hydrological service from the watershed up there. But the problem in the Mekong is not that simple, because there are country downstream, and the ecosystem downstream depends very much on the runoff, which is huge in the rainy season and then reduced in size in the dry season. And that is to produce a Great Lake in Cambodia. And if both China and Laos and Cambodia, Cambodia has one dam now, start building all the dams, what would happen is there will be a change in the ecosystem, the Tonle Sap ecosystem, the Delta ecosystem in Vietnam. This will affect the livelihood of the mangroves, the freshwater mangroves in the Tonle Sap. It will change the sediment level and also productivity of the downstream countries. So there is one study that the impact of damming will cost the country trade downstream more than 200 billion US dollars. So what seems to be benefit of one country would probably create a lot of difficulties to other countries. And I don't have any solution for this now, but I think what happened is all the countries will have to sit around the table and discuss alternatives or what we can do. Thailand, for example, understands the difficulty because now when the Chinese are damming the river, the Lanchanjiang, it has affected the fishermen in the upper part of Thailand. It has affected our navigation. Now only Chinese boats can travel because they know when the authority will release water. But the Thai boat cannot sail because we don't know when the water's coming. Sometimes the water will not come, sometimes the water will come. Because the regulation of the level of water is in China, a long way away. So it doesn't mean that Thailand does not understand the problem, but you have to take other people's problem into your consideration, and you have to put the data on the table and then see what are alternatives. For Thailand, we have difficulty. If we don't buy hydropower, we are now 70% of our electricity is from natural gas. So if we don't buy from Laos, we can buy from Malaysia, and we can buy from Burma, and we can buy coal from Indonesia, which is worse for climate change.
Thank you, Ming-san. Lou, I was impressed by, in our conversation earlier today, a comment you were making about how forests has really been put in a pigeonhole, and in international policy dialogues such as are going on in this city this week. And I was wondering if you could share with us your insights on that. How do you think that forests could come in a way that represents the full spectrum of its contributions to sustaining life on this planet?
Thank you, Dan. I think that's an important point. If you look at the zero-order draft, forests are mentioned primarily with respect to its relationship on biodiversity. And there's not a lot of text in the draft about where forests fit into these problems. In Rio, in the first Rio conference, we had the Declaration on Forests. We had UNFF came out of Agenda 21. And as long as we were talking about forests for the sake of forests, things didn't get very far. UNFF was originally supposed to give us an international convention on forests. That never happened. TFAP, the Tropical Forestry Action Plan, had some early actions and some early successes, but it never quite reached the scale that we had hoped that dealing with the problems of deforestation would happen. When initially forests were put on the table for climate change, everybody thought it was too difficult. It was taken off the table in 2001, 2002, as you mentioned earlier. In 2006, there was a window of opportunity to create it. Forests were back on the table. And I think what we've seen accomplished in the climate change discussions around forests have done much more for keeping tropical forests on the agenda and much more about raising awareness and discussions that are happening in countries over forest policy that haven't been happening for the past 20 years are taking place now. So, for example, in Indonesia, we have serious discussion about what to do about peatlands, what to do about peatland forests, what to do about the deforestation rates, and how to accommodate sustainable development of the country while maintaining forests and the functions that forests play in society. Now that we have forests linked with another agenda, with the climate change agenda, it took a while to make progress, but I think we're way beyond what we were able to achieve and way beyond the level of dialogue and discussion within many countries than when we were talking about forests for the sake of forests or forests for biodiversity. We now have a link with a major international agenda. To the extent that we can link forests with what's being discussed here in Rio, with the food security agenda, with the energy agenda. 90% of the energy in Africa comes from forests. People are burning wood, they're burning charcoal. If we can link forests with these agendas, I think we'll see much more progress, much more holistic view of forests of the forest and deforestation problem being brought into the discussions, and this is where we can make the progress. So if we're talking about forests just for the sake of forests and only the biodiversity section here in Rio, we're not going to have major progress on forests. If we can now link, and as a part of the whole objective of why we're here and convening this conference, if we can link forests with water, forests with energy, forests with food security, forests with green economy, that's where we're going to get the traction in the policy arena. And so I think that the days of forest for the sake of forest is over, and now we have to get forests integrated into these other areas of policy discussion.
Thank you, Lou. Inspiring. I want you to drill in. Could you drill into your last point a little bit? I think the idea of managing landscapes for evapotranspiration and related hydrological functions gets very little attention, and yet it's remarkably important. Could you elaborate on some scenarios in which your final point about using afforestation or reforestation as a broader landscape water management tool?
Yeah, I would like to tell you first with the statement that Carlos made. He was the... Right. Okay. I wanted to tie in first with the statement that Carlos made, and that is that the Copenhagen Climate Council came up with one of the conclusions that the next era of climate change adaptation will be about water. And I've tried to turn that around a little bit and say, well, wait a minute. The next era of climate change adaptation discussion will be about forests and water. Because without forests in that equation, we cannot address those crucial water issues. And so when you turn to the question of landscape management and how you deal with land use practices, you have to incorporate these ideas of the impact of land use change on the ET regime, right, the evapotranspiration.
We heard about the need to reframe forests in a way so that their functions, you don't let them get put in a box. They were put in forest for forest's sake as a box, as we pointed out. Now maybe they're too much in a carbon box. Forests are really much more beyond that. They're habitat. They are the homes, the cultures, the religions of many native people. They need, in and of themselves, an agenda that cuts across all of these themes. We have to get out of our silos if we're going to address forests in a particular way. And even though we can't attribute, do the sort of reference level that we can do for carbon emissions with evapotranspiration and the importance of that in global circulation systems, there certainly seems to be a very strong scientific base for a precautionary approach in which we basically say, if we've got forests, keep them. If they're gone from the land, we have to grow food. Most food crops don't do so well in the understory of forests. There are some important exceptions there, but we have to reconcile those two. And there's enormous areas around the world that could go back into forests, and that's probably one of the smartest things that humanity could get on with. For me, a lot of these things come home and are manifested if we think about the Amazon, which is certainly something the world has its eyes on. We've got the Belo Monte Dam moving forward, and the engineers of Eletronorte assumed typical hydrology when they looked at the dam and its ability to generate energy. They knew there was a seasonal dip. Recent research led by Claudia Stickler together with Marcos Costa, a climatologist, and Michael Coe, a hydrologist, points out though that actually it's just what David pointed out. It's those upwind forests that become very important in determining future flows of that river, and therefore the energy supply that's expected to supply 40% of Brazil's growth and demand by 2020. Unfortunately, the dam is going forward right now, but it looks like there's reasons to question its viability as an infrastructure project. We have to build this in, and imagine framing forests in that way. Forests of the eastern Amazon are critical to the existing hydroelectric systems that could gain a lot more political weight and a political momentum towards an agenda that keeps forests standing or gets them replanted. And these don't necessarily have to be native forests. Palm oil is a pretty good year-round transpirer. It's got deep root systems, it's evergreen, it pumps a lot of vapor into the atmosphere. And we need to bring that sort of transpirational logic and worldview to really get to systemic management systems across large continental and subcontinental landscapes. We now have 20 minutes left, and we're going to open it up to questions. Please keep your questions brief, and why don't we take 3 questions initially, and let us know who your question is directed to. And I think we've got Avesita, first question right there.
First, thank you very much for this excellent panel. It's very nice, thought-provoking, and all of that. My question goes to the panel, but particularly to Dr. Norway. Now that you are in a position of working with the government in policy and mentioning about this global regime, which could be very ambitious, but what about an Amazon-wide regime? Just like Dan mentioned, Belo Monte for Brazil, there's these parallel bilateral agreements of Brazil with Andean countries to build dams in the Western Amazon. And that potentially could cause a lot of changes in the regime of the Amazon as a whole. So what are your thoughts about these type of changes that may occur if dams are built in the upper Amazon in Andean countries?
One more question back here.
Hi, my name is Duncan Gomko. I'm with Johns Hopkins University. My question is mostly for David. How precisely are you able to estimate the change in precipitation and the change in location of precipitation as a result of land use change in a different location? It seems like this would be particularly important to get it precise if you're talking about PES programs for evapotranspiration. Thank you.
And one more. Raise your hand, please, again.
Wolfgang Benning, Germany. The question, parting from the position of Mr. Noble or Ellison, that the relation between forest and water might be more important, or the direct relation might be more important than the relation between forest and climate. No? The question to Professor Mingsan, what are the activities of the Thailand government as to investigate the capacity of infiltration or absorption in the upper area of the Mekong, Thailand area? There, as to information, especially through capacity of infiltration absorption, is a hydrological question. So you should know the areas where there is more infiltration absorption than the areas where there is less. And those areas should be better preserved on the way. So it's also a more theoretical question to Mr. Ellison, whether in this integrated approach of watershed management, the hydrogeological dimension generally is integrated. In the last Congress of LOC, this Latin American network of watershed areas, only 20% of the projects in all the areas, I think there are about 240 projects, are integrating the hydrological dimension, or not the superficial watershed, but the underground watershed. Thank you.
Okay, thank you. Let's start with Carlos on hydroelectric dams in the Amazon?
This is an important question. It's a tough question. Well, first of all, the current policy, at least in Brazil, is not to build very large reservoirs. So they basically ended. The policy does not call for accumulation reservoirs that would accumulate water, let's say, to take a 5-year drought. So the reservoirs are run-of-the-river reservoir. So that, of course, makes for a much smaller reservoir. And also, let's say that in the second half of this century, we really moved to a sustainable energy society, and that energy will come from the sun. Mostly 80% of the electricity can come from photovoltaics in the second half, towards the end of this century. And wind has a tremendous potential all over the world, in Brazil in particular, 3-4 times larger wind potential as compared to water. So I think really we are going to move away from water as a source of energy over the next 5 decades. So there is this transition period. You know, if I were able to say something important to my own government, I would say, slow down the implementation of new hydro dam projects. You know, move more rapidly in terms of wind and also solar. So in a way, really, not to build as many, or not to tap all the potential, because solar and wind will really be the source for the future. And also the run-of-the-river type of dams make it for much easier reversibility. It's not, of course, when you dam the river, you're never going to reconstitute the earlier original conditions as soon as this dam is decommissioned, but it's easier. So even, I would say, in the long run, we might even have a policy of reconstituting some of the functionalities of that river system at the time when hydropower will be no longer competitive with other sources, including and mostly solar. So I would say, you know, for the whole of the Amazon, is slow down, try to incorporate other renewables as fast as possible, and having these dams with much less impact. You don't remove the impact, always there is an impact. There's a local impact, communities, because they've been living there for sometimes thousands of years, or hundreds of years, indigenous communities. So you have to be very careful in democratic societies to respect the well-being of everyone. But I think most countries will continue with their policies, including Brazil. And Brazil is thirsty for energy. When you compare burning fossil fuel versus Amazonian hydro power, it's a tough question. It's a very tough question. Not easy answers. So I would say slow down the implementation, more other types of renewable, mostly wind and solar, and then perhaps within 100 years we will be free from hydropower all over the world.
Thank you, Carlos. David, do you want to respond to the question about uncertainty?
I think there were two questions. One was about change in precipitation with respect to change in landscape practices. And I think that it's actually a weakness in the literature that one of the things it doesn't do very well is talk about change. What we measure and look at for the most part so far is we say that the sources of precipitation in a basin are from X, Y, and Z, from oceanic evaporation, from evapotranspiration, from evaporation from water surface bodies, and so on. And clearly demonstrating the change, I think, is not done as well. It would be certainly a very nice thing to see more of in the studies that I've looked at. I don't think that that's handled all that well. We are sort of caught in a historical, technological bind in the sense that our ability to track ET is relatively new. And so being able to observe big changes over time is complicated. Most of the deforestation, say, across the North American continent has occurred many, many years ago, decades ago, and our ability to really track ET is relatively new. So there's an interesting gap there that perhaps could be filled with some studies, and I think that would be an interesting avenue to pursue. I mean, I have toyed with the idea of trying to compare the historical record with some of the outcomes, but that's another project for another day. The other question, I'm not so sure, was a question was about water and underbred watersheds being left out of water management budgets, essentially. The paper that I wrote was about essentially the role of forests in their atmospheric, so above ground impact on ET transport. And I keep threatening my colleagues and saying, I now want to write a paper on what happens under the ground. Because in many ways, I think that's the other half of the story that's not very well told. So how are freshwater resources stored on terrestrial surfaces, and what is the role of forests, among other things, in that general process, and what impact does that have on water availability overall? And I think we find a similar kind of story. That also is work that still needs to be done.
Yes, I have 2 points. The first one is, long time ago, since long time ago, Thai people believe that forest produces rain. Even when people are saying that no, forest produce a lot of water, it doesn't produce rain. In Thailand, a lot of people believe that. So we have high recognition for hydrological service of forest. Whether it is right or this is wrong, we don't care because we don't have good scientists like it. We just believe that forests produce rain. And the forestry department has been using this as a reason for people to protect forests. So I think if we can sort of clarify this and have scientific evidence and to tell people what it is all about, it would be much better than just having policy based on belief. Now, the second point is, after the mega flood, how we increase absorptive capacity of rainwater. The government is looking for swamp, low-lying areas to be retention pond for flood water. And to do, they are looking for very large amount of area, which is in the million hectares, actually 0.3 million hectares, and planning to pay the farmers there for not growing when the flood came, and to use the area for water retention pond, and divert it from the city into the low-lying area. It's a low-tech type of a solution.
I think we have time for 2 quick questions, very quick, right here in the front.
Thank you. My name is Koosje Hoogendoorn. I'm from INBAR, the International Network for Bamboo and Rattan. I want to link up to what Louis earlier was talking about, and that is that the role of forests in sustainable development, and not only related to climate or to biodiversity. Actually, yesterday there was an event organized by the FAO and the Brazilian forest industry, which was called Forest, the Heart of the Green Economy. And I think many important issues were discussed there that are related to this particular issue, and maybe it's a good idea to link up to the outcomes of that meeting in trying to influence the discussions of the next couple of days. But also there, it was mentioned what you alluded briefly on, that there is about 2 billion hectares in the world of degraded land. Possibly it was forest. Now, how are we going to put that land best back into forest in a way that it's both serving ecosystem services but also economical services? And are we doing enough science on reforestation? And if not, what is needed? It's mainly for Louis, but maybe also other people would like to comment on that. Thank you.
One more question, if it's very brief. Okay, we can go to the response then. Lou?
Yeah, thank you very much. I think this degraded land issue is something that needs a lot of attention. I've done a bit of work over the past couple of years with the Foundation for Ecological Security in India, and looking at their assisted natural regeneration approaches to trying to rehabilitate degraded lands. And I think we need to understand that there's a lot of discussion out there about we need to restore degraded lands, we need to put them back into productivity. There are tipping points out there, and a lot of the lands that we've been looking at cannot be recovered. You cannot put a productive forest, or there was any way it resembles the forest that was there originally, back on those lands. Degraded lands are degraded, and in many places we've already crossed tipping points. So we have to understand just how much these degraded lands can contribute to sustainable landscape management, but more importantly, I think we need to understand the importance of avoiding degradation in the first place, and that is not as well understood. It's a bit of a throwaway line in a lot of development. We talk about, well, let's produce jatropha on degraded lands. Let's produce biofuels on degraded lands and not compete with agricultural productivity. Degraded lands are not productive, and it takes a lot of energy and a lot of inputs to put them back into production. So yes, we have to do that, but more importantly, we need policies and we need approaches and we need incentives to not degrade these resources in the first place. And that's where we're going to get significant sustainable development. But having said that, there is a lot of degraded land out there, and not addressing that issue, not putting them back into production it's a lost opportunity. But we need to be realistic. It takes a lot of effort to put those back into production, and so they are part of the solution. But the ultimate solution is avoiding degradation in the first place.
And to wrap this session up, I will say about 40 seconds worth of words. And that is that I think we're coming into an era of scarcity. I think the bet between Julian Simons and Paul Ehrlich back in the 80s, Paul eventually was right. Prices of commodities are coming up after a decade of decline. And it's not the ecologists who are coming to this conclusion, it's the asset managers like Jeremy Graham and Grantham and others. What it points to is the need to retool our economy. Our economy is still essentially based upon economic transactions as the measure of wealth, instead of the capacity of the earth to sustain life as the measure of wealth. We've learned that some of the most important ecological functions that sustain life on the planet are very difficult to measure and to monetize, but we know they're there. And we have to figure out, for anyone who was in this city 20 years ago and felt the inspiration of these magnificent new global treaties rolling out, and looks back over what we've learned in the last 20 years, it's basically that we need a new model. It's got to be much more bottom-up, but it has to be looking at the global constraints on what this population of Homo sapiens can really expect to do over the coming decades on a finite planet. I think that we've learned that forests, boy, the anticipation we had in 2006 that we were really going to come up with a robust global carbon price signal that would include forests, that was historic. We've learned that it's not that easy, that when push comes to shove, a little financial crisis comes along, and suddenly the big political powers of the world back away and they look at their own bank accounts and realize that environment and the capacity of the earth to sustain life is just not that important. So something has to change. We need to have that global framework, but pushing from the ground up and identifying those sources of innovation that are out there right now. And I think a lot of them are being presented. The speaker right after coffee break here is the new Minister of Environment from Norway. Norway, I think, has shown very well that a single nation with political will can make a difference on an enormous global issue like forests. It doesn't hurt to have a little bit of North Atlantic oil. Following that, at the end of the afternoon, beginning at 6:30, we'll have 3 governors in here who are making big changes in their states towards a new economic model of rural development. And those are 3 governors from the Brazilian Amazon. So thank you for your time. Let's now give a round of applause to their panelists and enjoy our coffee.